Okay, so this is my project on conic sections and analytic geometry. These are the conic sections, and conic sections are curves that result from the intersection of a right circular cone and a plane. We have a parabola, circle, ellipse, and a hyperbola. Real-life examples of ellipses are the Batman symbol and some shaped foods like eggs and lemons. And real-life examples of parabolas are like roller coasters and certain shapes that you can make from waterfalls that are like not necessarily a half circle, but more of a half ellipse. A real-life example of hyperbolas are the red lines on a baseball as they curve but never do intersect, and kind of like the outer perimeter of a tower or a nuclear power plant vapor tower. As you can see, the perimeters shape, but they never touch. Ellipses. An ellipse is the set of all points in a plane whose sum, an ellipse is the set of all points in a plane, the sum of whose distances from two fixed points is constant. The standard form of the equation of an ellipse centered at the origin can be written in two ways, one being a horizontal axis and vertical major axis, and those are our two equations to solve such. Graphing an equation of an ellipse. In this equation, 25x squared plus 16y squared equals 400. We want to graph and locate the foci. We begin by expressing the equation in standard form. Because we want 1 on the right side, we divide both sides by 400. The equation is the standard form of an ellipse's equation with a squared equals 25x and b squared equals 16. Because the denominator of the y squared term is greater than the denominator of the x squared term, the major axis is vertical. Based on the standard form of the equation, we know the verticals are a and negative a, or 0 and negative a, and 0 and a. Because a squared equals 25 and a equals 5, thus the verticals are 0, negative 5, and 0 and 5. Now we have to find the endpoints of the horizontal minor axis. According to the standard form, these endpoints are negative b and 0 and b and 0. Because b squared is 16 and b is 4, thus the endpoints are negative 4 and 0 and 4 and 0. Then we find the foci, which are located at 0 and negative c and 0 and c. Because b squared equals a squared minus c squared, a squared is 25 and b squared is 16. We can find c as follows. A squared equals c squared equals a squared minus b squared equals 25 minus 16 equals 9. Because c squared equals 9 and c equals 3, the foci 0 and negative c and 0 and c are located at 0, negative 3, and 0 and 3. And that's what our endpoints look like on the major and minor axis. Alright, real-life application involving an ellipse. Let's say a semi-elliptical archway has a height of 20 feet and a width of 50 feet, as shown in the figure below. Can a truck 14 feet high and 10 feet wide drive under the archway without going into the other lane? In the figure above, we construct a coordinate system with the x-axis on the ground and the origin at the center of the archway. Also shown is the truck, whose height is 14 feet. Because the right side of the truck is 10 feet from the center of the archway, we must find the height of the archway 10 feet from the center. If that height is 14 feet or less, the truck will not clear the opening. Alright, applications involving an ellipses continued. Using the equation x squared over a squared plus y squared over b squared equals 1, we can express the equation of the archway as x squared over 25 squared plus y squared over 20 squared equals 1. As shown in the figure, the right edge of the truck corresponds to x equals 10. We find the height of the archway 10 feet from the center by substituting 10 for x and solving for y. So the next step would be to clear the fractions by multiplying both sides by the least common denominator, which is 10,000. Then we want to use the distributive property following by simplifying. Then we subtract 1600 from both sides, divide both sides by 25, and we take only the positive square root. The archway is above the x-axis, so the y is non-negative. Thus, the height of the archway is 10 feet from the center. It's approximately 18.33 feet. Because the truck's height is 14 feet, there is enough room for the truck to clear the archway without having to merge into another lane. Okay, so now we're on a parabola. Parabola is the set of all points in a plane that are equidistant from a fixed line. The standard form of the equation of a parabola with vertex at the origin is 4px, or x squared equals 4py. The graph illustrates that for the equation on the left, the focus is on the x-axis, which is the axis of symmetry. For the equation of the right, the focus is on the y-axis, which is the axis of symmetry. Okay, so now we're going to graph the equation of a parabola. We have to find the focus and directrix of the parabola given by x squared equals negative 8y, the graph of the parabola. We are given the equation in standard form, x squared equals 4py, so 4p would equal negative 8. We can then find both the focus and the directrix by finding p. 4p equals negative 8, and p would equal negative 2. The focus on the x-axis, or on the y-axis, is at 0 and p, and the directrix is given by negative p. Because p is less than 0, the parabola opens downward. Using this value for p, we then obtain the focus and the directrix. To graph x squared equals negative 8, we assign a y value that makes the right side a perfect square. If y equals negative 2, then x squared equals negative 8 times negative 2, which is 16. So x is 4 and negative 4. The parabola passes through the points 4 and negative 2 and negative 4 and negative 2, as seen on the right. Alright, applications involving parabolas in real life. Let's say an engineer is designing a flashlight using a parabolic reflection mirror and a light source, shown in this figure on the right. The casting has a diameter of 4 inches and a depth of 2 inches. Let's find the equation of the parabola used to shape in the mirror. At what point should the light source be placed relative to the mirror's vertex? So we want to position the parabola with its vertex at the origin and opening upward. The focus is then on the y-axis located at 0 and p. We use the standard form of the equation in which there is y-axis symmetry, namely x squared equals 4py. We need to find p, and because 2 and 2 lies on the parabola, we let x equals 2 and y equals 2, and x squared equals 4py. We then substitute half for p and an x squared equals 4py to obtain the standard form of the equation. The equation of the parabola used to shape the mirror is x squared equals 4x half y, or x squared equals 2y. The light source should be placed at the focus, 0p, because p equals half. The light should be placed at 0 and 0.5, or half inch above the vertex, as shown in the right-hand corner. Okay, so now we're moving on to our final piece of the conic section, which is the hyperbola. A hyperbola is the set of points in a plane, the difference of whose distances from two fixed points is constant. The standard form of the equation for a hyperbola with the center at the origin is x squared over a squared minus y squared over b squared equals 1. or y squared over a squared minus x squared over b squared equals 1. The left equation has a transverse axis that lies on the x-axis, shown in the graph on the bottom left-hand corner. The right equation's transverse axis lies on the y-axis. The verticals are a units from the center and the foci are c units from the center. Alright, so now we're going to graph the equation of a hyperbola. Find the standard form of the equation of a hyperbola with foci at 0 and -3 and 0 and 3 and the vertices at 0 and -2 and 0 and 2. Because the foci are located at 0 and -3 and 0 and 3 on the y-axis, the transverse axis lies on the y-axis. The center of the hyperbola is midway between the foci, located at 0 and 0. Thus, the form of the equation is y squared over a squared minus x squared over b squared equals -1. Then we need to determine the values for a squared and b squared. The distance from the center, 0, 0, to either vortex, 0, -2, or 0 and 2, is 2, so a equals 2. Y squared over 2 squared minus x squared over b squared equals 1. Or y squared over 4 minus x squared over b squared is also 1. Then we have to find b squared. The distance from the center, 0, 0, to either foci, 0 and -3, or 0 and 3 is 3. Thus, c can be equal to 3 because b squared is equal to c squared minus a squared. We have b squared minus c squared minus a squared equals 9 minus 4 equals 5. Substituting 5 for b squared in the last equation gives us a standard form for the hyperbola's equation. The equation is y squared over 4 minus x squared over 5 is equal to 1. And we can see the hyperbola in standard form graphed on the right-hand side of the screen. Okay, real-life applications involving hyperbolas. So let's say an explosion is recorded by two microphones that are 2 miles apart. Microphone M1 receives the sound 3 seconds before microphone M2. Assuming sound travels at 1,100 feet per second, determine the possible locations of the explosion relative to the location of the microphones. We begin by putting the microphones in a coordinate system, as shown on the graph. We know that M1 received the sound 3 seconds before M2 because sound travels at 1,100 feet per second. The difference between the distance from P to M1 and the distance from P to M2 is 3,300 feet. The set of all the points, P, or the locations of the explosion, satisfying these conditions fits the definition of a hyperbola, with microphones M1 and M2 at the foci. We can see the two locations of the microphones on the x-axis and P on the x and y coordinate, which is the explosion. We will then use the standard form of the hyperbola's equation. P, x and y, the explosion point, lies on this hyperbola, x squared over a squared minus y squared over b squared equals 1. The differences between the distances 3,300 feet. Thus, 2a equals 3,300 and a equals half of that, which is 1,650. X squared over 1,650 squared minus y squared over b squared is 1. Okay, the distance from the center, 0, 0, to either foci is negative 5,280 and 0, or 5,280 and 0. Thus, c equals 5,280, which is how many feet there are in a mile. C squared equals a squared plus b squared, translates to 5,280 squared equals 1,650 squared plus b squared. B squared then equals 25,155,900. The equation of the hyperbola with a microphone at each focus point is x over 2,722,500 minus y squared over 25,155,900 is 1. We can then conclude that the explosion occurred somewhere on the right branch, closer to microphone 1 of the hyperbola, given by this equation. That concludes my presentation. Thank you for watching. My sources were Robert Blitzer, the author of Algebra and Trigonometry, 5th edition, our textbook in Math 22.